Continuing on our conversation about stoichiometry, so far we've covered how to convert from moles to moles and from mass to moles, but now we're going to convert from mass to mass. So I'll give you a few seconds to pause the video and copy this down. Okay, so we're continuing on with the same equation we had before. And we're adding really in just one more step. And for this, when we're converting from mass to mass, we must calculate the molar masses of the known and unknown substances. So we have to convert to molar mass both substances in the problem. And in this case, the oxygen and the P4. So my question is, what mass of oxygen will react with 1,239 grams of P4? So I start out my problem. I have 1,239 grams of P4. I have to convert to moles because all of these calculations, the conversions are done in moles. So I need the molar mass of P4 on the bottom. I found that in my previous section, that was 123.9 grams of P4 in 1 mole of P4. And now I'm able to use my equation to convert from one substance to another, because I know that 1 mole of P4 will react with 5 moles of oxygen. Now, crossing these out to make sure that I'm canceling, I know that 1 mole of oxygen has a molar mass. Well, I don't quite know that yet, but I can go down here and I see it's 2 times. Now, from my periodic table, the molar mass of 1 molecule or atom of oxygen is 16, so I get 32 grams of oxygen. So up here, 32 grams of oxygen. Now I am in mass, so I can multiply through the top and divide that by the bottom. And what I get is 1,600 grams of oxygen. Now in this problem, what you will notice is I have a molar mass here. I have my mole ratio here. And I have another molar mass here. So when I'm doing a mass-to-mass problem, I like to call these a molar mass sandwich because the meat of the problem is my mole ratio. And the bread is the molar masses. So a mass-to-mass conversion is what I call a molar mass sandwich. Now, when I'm doing a mass-to-mole conversion, this is like an open-faced sandwich. I have my molar mass, which is the bread, and my mole ratio, which is the meat that I put on top. So that's an open-faced sandwich. And when I'm doing my mole-to-mole problems, which I don't have the paper here because I did the video the other day, I just have the mole ratio. And so I would just say that that's just the meat. Okay, so mole to mole, you just have the meat. Mass to mole, you have an open-faced sandwich, and mass to mass, you have a molar mass sandwich. So that's one way you can remember how to do these problems. Now let's go on, and I will give you a few extra problems. Oh, sorry, number of particles. There's one more type of problem. I forgot. So sometimes they'll want to know the number of particles or give you the number of particles. And so here is one more thing that we can do with this. So I'm given how many oxygen molecules will react with 1,239 grams of P4. So I start out with my 1,239 grams of P4. From my previous problems, I know that 123.9 grams of P4 is 1 mole of P4. Now I need to go from phosphorus to oxygen at this point. So I put here, I have a coefficient of 1 out in front of my P4, so 1 mole of P4. I have a 5 in front of my oxygen, reacts with 5 moles of oxygen. Now, at this point though, I want to go to number of molecules. And remember, I know that 1 mole of oxygen contains Avogadro's number, 6.022 times 10 to the 23rd molecules of oxygen. Our moles cancel there. So when I multiply across the top and divide that by what's on the bottom, I get 3.011 times 10 to the 23rd molecules of oxygen. Now in this case, in this problem, I have my molar mass. I have my mole ratio, which is my meat. And at the end, I have Avogadro's number. And so that's how you do a problem with particles. And if they gave you the particles first, you would just do it backwards. You would do Avogadro's number, then your mole ratio, and then your molar mass if you're trying to go from number of particles to mass. So you would just do that the other way around. So now I can go to showing you some problems. So I'm going to show you page 236, questions C and D from number 1. And so I am given this reaction. I'm going to write down the formula so you can see it. Maybe. There, that's better. So that's my reaction. We've already done parts 1 and 2, or A and B, so I'm going to go to C. And the question is, what mass of iron metal is needed to form 100 grams of rust? So I have 100 grams. Whoops. Let's keep the right number of significant digits, right? So 100 grams of rust, Fe2O3. I'm going from rust to iron, so I need to convert this to moles. Down here, I need to do a molar mass. So Fe2O3 is 2 times, from my periodic table, 55.8 0.85 grams plus 3 times 16 grams. When I multiply those numbers and then add them together, I get 159.7 grams of iron 3 oxide. Now I go back up into my problem and I write that number down. And that is 1 mole of rust. Now here's my mole ratio. So I have my bread here, my molar mass. I need my meat, which is my mole ratio. So I know from my equation up here that 2 goes on the bottom because I have iron, 2 moles Fe2O3. Now I'm going to iron, so that's 4 moles. But I want, of just iron, 4 moles of iron. But I want grams of iron, the mass. So I know that 1 mole of iron, now from my periodic table, and it's the same number as here, it's 55.85 grams of iron. So when I multiply across the top and then divide that by what's on the bottom, I get an answer of 69.94 grams of iron. And that is my answer. Now remember, I have my molar mass, my mole ratio, and my molar mass here. I have a molar mass sandwich for this problem. Going to problem D. The question is, how many molecules of oxygen will be needed to react with 50 grams of iron metal? So I have my 50 grams of iron. I can't do anything until I convert to moles. So 55.85 grams of iron, which I found off of my periodic table for this problem. So I'll just use those same numbers. No sense making more work for myself. And that is 1 mole of iron. Now that I'm in moles, I can use my equation up top. I have 4 moles of iron. And I know that that reacts with 3 moles of oxygen from my equation, because there's a coefficient of 3 in front of that oxygen. Now, they want to know about molecules. So I have to go from moles to molecules. And I know that 1 mole of oxygen contains 6.022 times 10 to the 23rd molecules of oxygen. So when I multiply across the top and divide that by what is on the bottom, I get an answer of 4.04 times 10 to the 23rd molecules of oxygen. And here, remember, for this type of problem, I have my molar mass, I have my mole ratio, and I have Avogadro's number. So this is like an open-faced sandwich with guacamole on top, because I have my bread, my meat, and Avogadro's number, which sounds a lot like avocado. So that is how you do this type of problem. You should be set for doing your homework now, which is page 241, question number 21 and question 22, C through E. We've already done A and B, so I'll be back with how to do those next.